So today's webinar is in fact a bilingual event available to attendees in both English and French. All speakers today will in fact be speaking English. However, we have live interpretation available via the interpretation function within Zoom. So you should all be able to see a globe interpretation button at the bottom of your screens. Just indicated by the picture on the right at the top there. If you are lucky enough to be bilingual and you don't need any translation, you need to do nothing as it's set to off as default. However, if you would like to hear everything in English, please do select English, or if you would like to hear everything in French, please select French. Just a note to everybody that this webinar will be recorded and we will make it available through the Tiger website after the event's complete. Next slide, please. So just a very quick introduction to the Tiger project. The Tiger project led by the Offshore Renewable Energy Catapult. My name is Theo van der Kammen and I'm a technical manager at the Catapult. And the Catapult is the UK's leading not-for-profit technology, innovation and research centre for offshore renewable energy. We are lead partner responsible for coordinating the Tiger project, which is Interreg's largest ever funded tidal stream project, of which of the 45.4 million euros, approximately 30 million is ERDF funding, which we must acknowledge. Next slide, please, Carly. So on your screen now, you can see a map on the left-hand side. The dark shaded area is in fact the Channel Manche region, the region that this funding is focused towards. We're also indicating where some of the 18 partners are located. There are a few that aren't on this map as they're off screen, so to speak. You can also see the locations of the tidal stream sites that we're actively consenting or developing. So you can see Ramsey Sound off of the Pembrokeshire coast in Wales. We have the PTEC site and also the Yarmouth demonstration site off the Isle of Wight. We have the Ras Branchard site where there are two tidal commercial pilot sites being consented. We have the Pampol Brehat tidal test site owned and operated by EDF. And we have the Morbihan Gulf project, again, seeking to gain consent and hopefully install turbines later in 2022. The main objectives, sorry, just go back, please, Carly. The main objectives of the Tiger project are to address technology challenges within the tidal stream sector. The big focus for today is building supply chain. So we really want to get to grips with supply chain capability and the potential for growth in future. And as I just mentioned, we're switching on new tidal sites and installing turbines across the Channel area. Next slide, please. So today's webinar will travel around and focus on the UK tidal stream projects and the opportunities there for both local and regional supply chain companies. As I mentioned, we actually had a Meet the Buyer webinar last week on the 10th of June, where we heard from all of the Tiger tidal sites off of the French coast. So if you are interested in hearing what they had to say and what the supply chain opportunities are for those sites, the recording will be made available via the Tiger website. Thank you, Carly. Next slide. So just a quick run through the agenda today. So first site we'll be introduced to is the Ramsey Sound Tidal Regeneration Project, where Sue Barr will take us through. We'll follow each presentation with a short 5-minute Q&A. So please do post any questions you have for that speaker in the using the Q&A function at the bottom of your screen. And I'll chair a short Q&A session where Sue can answer some of those questions. We'll then be moving on to the Yarmouth Harbour demonstration site, where Keith Murray from QED Naval will present on that project, again followed by the 5-minute Q&A session. And lastly, we'll have three speakers actually giving us an overview on the PTEC project, again followed by a short Q&A and an open forum. Next slide, please, Carly. Okay, so now's time for me to stop talking and I'll hand over to Sue.
Good morning, everyone, and thank you, Theo, for the introduction. I'm going to give you an introduction to the Ramsey Sound Regeneration Project. And as Theo highlighted to you, this project is actually off the coast of Wales, so slightly outside of the Channel Manche region, but an important project nonetheless. And hopefully I can take you through what we are hoping to achieve at this site. So the site itself is already an operational tidal stream deployment location. Here we have a 400 kilowatt tidal turbine that is deployed in Ramsey Sound. That's an area, if you can see at the top of that photograph, that area of water off the beautiful Pembrokeshire coast in Wales. And we have that turbine has been deployed for quite a long time. What we're hoping to do with this site is recover that turbine, refurbish it, and redeploy into this site to keep this site operational. So the interesting part about this project is that we have a fully operational and consented site that is ready within a relatively short time period to redeploy an operational turbine. We have an onshore substation which sits just behind that lifeboat station, so you can see the building in the top photograph. And we have a cable that runs to the grid, so we are grid connected, and then out to the island where we have a tidal turbine deployed. It's an interesting site as well because it is fairly strong tidal flows, and we know that we have had an operational period of this turbine. So really we want to achieve learning from the turbine that has already been deployed, but then look again at a new turbine that can be deployed during the time of the Tiger project. So very interesting. Next slide, please. The company Cambrian Offshore Southwest Limited was set up really to engage with the Tiger project, which you have heard is a 45 million euro project. We know that it will be very, very important to take the data from the operational turbine and feed that into other sites, both in terms of how the project was deployed, how it behaved operationally, and also the redeployment. So there's some interesting information that can be taken from this project and shared to the 18 project partners across Tiger. As I said, it has a grid connection, which is really, really important for these projects in order to understand how we're going to generate electricity and also how we're going to reduce costs in utilizing the grid. So great to have that infrastructure in place, but there are a number of steps that we need to go through now in order to deliver an operational program. Next slide, please. So what are those stages and how can the supply chain or other organizations engage in this project? And we are trying to be as open and as transparent as we can with the project so that the data derived from it can be used as broadly as possible. But in short, we have 3 stages. And at the moment, we're in stage 1. We've done a lot of preparation to look at retrieval of the turbine. And you can see in the top left-hand corner, this is the Delta Stream technology. It was developed by Tidal Energy Limited and deployed back in the late 2015. So it's been in the water for around 6 years. It has not been operational for that full period, but the intent is to retrieve that turbine and look at how it has performed during that time. So there's some interesting information around elements such as corrosion of metal, hydraulics, how we think that turbine has behaved in a very strong tidal flow for 6 years. So our next stage is to go and recover the turbine. We started the procurement process for that in late 2019. Due to COVID and various other delays, we've not yet gone and retrieved the turbine. And we're now in a period of heightened activity in order to go and retrieve that turbine. So we're in stage 1 at the moment. And the main components of that element of the work have been procured and tendered for. The next stage is to bring the turbine to shore. So we will find a workable area We anticipate this will be within Pembroke Dock at the moment, where the turbine will be laid to landside. So the cable will be disconnected, the turbine will be raised to the surface and brought to shore. Once we have the turbine in a secure position, we'll be looking to really investigate and understand all elements of the turbine, from the material science to the behavior of subcomponents to any additional environmental data, so biofouling that we can derive. And we're starting to reach out into the supply chain to help support that work. Primarily, this has been with companies and suppliers that supplied the components to TEL for the original deployment. However, we will be engaging across the project partners. So if you have a company that is interested in subsea behavior of paints or behavior in terms of metals, or just the longevity of these structures, decommissioning, etc., we'd like to hear from you, because we're hoping that we can use this turbine to really learn about how tidal turbines, tidal in-stream turbines, behave for long periods on the seabed. We're also going to look at whether we can refurbish that subsea base. So we have a large piece of engineering there, a triangular-based foundation, and what we would like to do is upgrade that to hold another turbine to redeploy. However, that may not be possible, dependent on the status of that turbine at the time of retrieval. So we're also looking to the supply chain, so turbine suppliers who may be able to provide technology for redeployment in stage 3. So a lot of the main majority of work that we will undertake, where we will be engaging with the supply chain, will be in stage 2. And I'll show you a timeline as to where stage 2 is likely to begin on the next slide. Stage 3 is the redevelopment. So there will be a number of elements of redeployment, but also testing of cables and ensuring that the onshore infrastructure, so the control panels, the electrical high voltage control that we have onshore, is suitable for control and operation of the new turbine. So we're likely to be seeing some upgrades of control systems. There may also be the opportunity for redeployment of monitoring equipment, and we are working with a number of the academic institutes across the project to look at how we can get the best data from the second deployment of an operational turbine. So phase 2 will see us, stage 2 will see us doing some refurbishment, some upgrades, engineering and rebuild. And effectively, I think that is where we have the majority of the supply chain engagement. Next slide, please. The overall objectives of this project really are to learn about how we drive out cost, how we operate the turbines onto the grid, environmental information, and really how we maintain infrastructure for these types of projects. You would have noted that earlier we stated this project is in Wales. Wales has a fairly prominent ability for marine energy. There's some good projects coming forward, but nothing in the water as such. So we're hoping to get a redeployment of a tidal turbine into that environment to help inform the project, but also inform developments within the UK. And we really want to get the best data we can from that deployment, because we feel that open source data, the ability to go and look at monitoring data, operational data, performance data, will be very, very important for the sector, particularly for Tidal Stream. Next slide, please. So I talked about the 3 stages, and really here is a timeline as how we expect this to develop and to unfold from a supply chain element piece. So as I stated, we're about to move into phase 1. Phase 1 is the recovery of the Delta Stream turbine, which we have already gone out to procurement for that, for the marine operations, for retrieval of the turbine. Once that turbine is on shore, and we expect that to be late July of this year, then there will be a number of elements of work, both investigating the turbine, but also looking at how we will rebuild that turbine and whether we want any additionality. So any new features, whether we need to upgrade anything. And there again, we'll be looking at onshore manufacturing, supply of components, and we may need some upgrades there of the turbine. So really that's going to be a critical element in terms of providing another operational turbine into this project. There'll also be site surveys. So we're anticipating that we do need to reinvestigate the site. So we want to be able to monitor what happens when you retrieve a turbine. So some of those operational parameters during the retrieval, where we can collect data on things like loading, on how we utilize vessels in high flow environments, the immediacy of looking at biofouling, for example, when we retrieve the turbine. And then when we go back into the site, we will need to have good data to inform the as-laid position of the turbine, the reconnection of the cable, the onshore testing and the upgrades of the onshore facilities. We expect commissioning of an operational turbine to be around the beginning of next year, so Q1 2022. We're already engaged with a number of turbine manufacturers, and we haven't tendered the work for the redeployment yet. So there's an opportunity there for marine operations and some of the ancillary works around the redeployment as well. And then we move into a period of operations. And again, this is highly critical to the project in terms of deriving the best information. So we will need to monitor, we will need to understand how that turbine is operating, both in terms of performance and its interaction with the environment. And the onshore works, how we can keep those and upgrade them. So there'll be a lot of electrical infrastructure interfacing, which will be very important for the project. Next slide, please. How we engage, we are talking directly to suppliers, but we are also using normal procurement mechanisms, so contracts finder, etc. We have a website which will be live, and we'll be posting updates in terms of up and coming work moving forward into the project. And we will shortly have an updated procurement plan for the new programme, as I have set out in these slides. My contact details are at the end of this, and I'm happy to take questions, but please do feel free to come directly to us in terms of the opportunities as we set them out in those 3 stages. Next slide, please. So thank you. That is a brief overview of what we hope to achieve with quite a ambitious project. We have a short timeline, so we're expecting to be speaking to the supply chain quite extensively over the coming months. As you would have seen from the project programme, this has been compressed. We're doing a lot of activity in the next 6 months of this year. And I look forward to working with you all to hopefully deliver an operational tidal turbine within Ramsey Sound that will help us understand more about tidal stream and driving out those costs. So thank you very much, and I'm very happy to take any questions.
So thank you very much for that presentation. We do have a couple of questions for you. I would just urge anyone who does have a question for Sue, if they could post them via the Q&A function. Sue, obviously there's a substantial amount of marine operations required for the retrieval of the device and potentially the redeployment of a new machine at Ramsey Sound. What's the status of the procurement for that service?
For the redeployment, we haven't gone out to procurement yet. So we are planning for, at the moment, the recovery. As I said, that's already been awarded. But we would anticipate that we would be looking for to talk to those who would be interested and taking expressions of interest within the next couple of months. Okay.
We have another question here about, so you mentioned the turbine's been in the water for the last 6 years. Has it been monitored, and is there data for that 6-year duration? And will that data be made available at all?
Yeah, so we have run in inventory on some of the monitoring techniques that are available during that period. So we've had a number of pieces of equipment on the turbine that have allowed us to monitor. The turbine actually only operated for around a 3-month period, and that was when the project was then put into administration. So we have that operational data. We have some interesting data on loading through some strain gauges, and we have some hydrophone data as well. We have a summary report that I can share, and then we've got the underlying metadata, the data that sits behind that we can also share. So there is some information on that. I think once we retrieve the turbine, we'll also have a whole new suite of information as well. So that will be made available when it has been worked up.
Great. We have another question here as well about the once the Delta Stream has been recovered and is along at the quayside, will perhaps those historic suppliers that supplied equipment for that machine be able to engage and perhaps do their own bits of analysis to inspect how their equipment has stood the test of time being submerged for that long?
Absolutely. So we're already talking to some of the suppliers, but if you are one of those and you've supplied components into Delta Stream, we'd be delighted to have you engage with us. The whole purpose of this project is there is not often an opportunity when a full tidal turbine, a full-scale tidal turbine is decommissioned for this type of forensic investigation. So we are hopeful that we can provide as much information as we can through having the turbine on shore. So absolutely, please do get in touch.
Great, thanks, Sue. And also another question here is, so once you do redeploy at Ramsey Sound, have you got a predetermined duration for that new deployment?
No, so our licenses will allow that to continue. We would hope we can keep it in the water if we have an operational turbine for as long as possible. Obviously, to derive the best data that we can, we want to keep the turbine operational for a long period. That will be dependent on the technology we use and whether there's a next phase to that. So we're already in discussions as to what is the best possible use of the site for turbine technologies. We're effectively providing the infrastructure. We're less interested in the turbine itself. We're not developing technology, but the site should really be continued use because of the fact that, you know, it takes a long time to get these sites developed, to get the infrastructure in place. So ideally, we would want operational turbines in that site for a long enough period with monitoring, so that we get good, really good, solid data on what operating tidal turbines in these types of environments means for Wales and for the Tiger project.
Thanks, Sue. We just got another question here with regards to data and asking what the primary source of tidal stream planning data is in terms of, you know, predictions and forecasts for planning operations. Are you using historic data that you've collected at site, or are there other sources that you use?
Yeah, so we work with the marine contractor on tidal windows, but we'd also rely on ADCP data, so we can look at behavior over depth of tidal flows, which can give us some interesting insight. But standard hydrographic data is used as well for when you would anticipate being on site within an operational window. And we know that, you know, the periods of slack tide, or the periods when the tide isn't flowing fully through the whole column, are very small. So you need to be well prepared in advance of that and have vessels located proximate to site very quickly before that. So there's a lot of planning around that we do with marine contractors. And obviously, timing with this project will be key, because there are elements of data collection that we want to take part in that are time constrained. So the biofouling, for example, you almost need immediate footage of the structure in a vertical axis to be able to really understand what that is. We're also hoping that we can use the historic data and some on-site measurement of flows, so that we're getting a real-time analysis of what happens during lifting very heavy structures from the seabed. So it's one area that isn't particularly well studied, or that there isn't a lot of data around what happens when you have vessels on site. So we're going to try and extrapolate some of the data from the lift in order that we can get some really good values on what happens when you're lifting these large structures to vessels.
Thanks, Sue. And I've got one last question for you, and I'm not sure how you might answer this, but basically asking which turbine manufacturers are you working with? And I'm assuming this might be for the redeployment at Ramsey Sound. I mean, I'm not sure whether you can name names, but what constraints are there in terms of the project envelope at Ramsey Sound? Are we going to be seeing floating devices, for example, or are they going to be quite similar to what we've seen in the past, or haven't seen because it's been submerged?
Yeah, so that's a good question. So commercially, we're speaking to all of the leading tidal turbine manufacturers. What we wanted to do with the site is make sure that it can be utilized and it fits with the project development or the technology development pathways of developers. There's no point in providing a site for deployment if it doesn't fit with the need of the technology at the moment. However, it is a sensitive site. It is an area that has huge interest from the local community. It's an area that is it's very beautiful. We have the Pembrokeshire National Coastal Park, and we have the Pembrokeshire National Path, which sees about 60,000 people a year wanting to look across to Ramsey Sound. Ramsey Sound is also an area of high tourist interest in terms of vessels going out for marine mammal observations and to the island itself. So we anticipate the turbine will be fully submerged. We anticipate that it will fit within the envelope of the consent. So it will not be a multi-megawatt machine at this stage. And we anticipate that it will utilize the existing infrastructure. So we won't need additional infrastructure for that project. And really that's to fit with the existing licenses, consents, leases and permits that we have at the site. So fully submerged turbine in a similar arrangement to how it is at the moment with Delta Stream.
That's great, Sue. Thank you very much. I think we've come to the end of this Q&A session now, but if anyone does have any burning questions they'd still like to ask Sue, then please do put them in the Q&A. And I think Sue might be able to respond to those throughout the remainder of the event. Okay, so I think now's time to move on to QED Naval's project at the Yarmouth demonstration site. So if I could introduce Keith. Keith, over to you.
Thank you, Theo. Good morning. My name is Keith Murray, and I'm the Chief Commercial Officer for QED Naval Limited. What I'd like to do today is really give you a little flavour of what we at QED are all about, a little bit about our foundation system and our Torqeedo turbines, and really explain what the Tiger project means to us in terms of particularly the supply chain opportunities around Yarmouth Harbour. And then, as we've just done before, we will have a 5-minute question and answer session. Next slide, please. QED was founded in 2008 by its CEO, Jeremy Smith, who quite simply had a passion for all things renewable, and in particular had a focus on the cost of marine operations, particularly when it came to deployment and the cost of around shipping. Jeremy's background was Ministry of Defence. He had been in Kinetic and was the design lead in projects such as the HMS Queen Elizabeth and on the world's largest composite propeller systems. He took this skill and experience and set up QED with a team of project engineers and naval architects, and then using really advanced numerical modelling systems that went on to design and develop what is a self-deploying foundation system for tidal turbines, which we simply call SubHub. Since 2008, SubHub has been continuously developed and modelled and has been at sea now off Ireland for just over 2 years. More recently, QED has seen a lot of growth and expansion, particularly with the acquisition on joint venture with Torqeedo Turbines and in Yanga Hydrowing, and then the acquisition of the Oosterschelte OTP Dam project in Holland, where it evidences its T2 turbines. And it's now seeing itself as a tidal energy provider with its first project here on this, the EU Tiger project. Next slide, please. QED's project is really all around our SubHub and our where we've been in the water with our patented self-deploying system for just over 2 years now. The SubHub is a readily deployable easy to transport, plug and play foundation system. It is currently being moved from Ireland to be refitted in Pembroke Dock at Mainstay Marine. It's independently been proven and verified as safe for 2 years, and up to date has shown evidence of cost savings and additional yield through design. Next slide, please. Since 2008, QED has really been in this continual path of development, culminating in the EU Tiger project, and has developed its unit through continuous tank testing and modelling. It is now really it's positioning itself now to evidence its new technologies through the Tiger project. Next slide, please. QED's acquisition of Tidal turbines brought with it a very well proven bi-blade design turbine, which has been to date well tested and in the water for over 10 years. It also brought with it a joint venture partner in Hydrowing and their operational skills and experience. Tidal's turbines have been in evidence in the Dutch government and Netherlands' iconic OTP dam, where our T2 turbines were installed in 2014 as part of an 18 million project with Huisman and the Rijkswaterstaat. This has already given us much live data around energy revenues, which will help support the Tiger project. Next slide, please. The QED's Tiger project showcases tidal energy in the UK based around Yarmouth Harbour on the Isle of Wight. We're currently working with Yarmouth Harbour in developing the site, obtaining permits, consents and licenses, and undertaking various site studies. We will then go on to perform basically 2 parts to our project. The first being the showcase of our sub-hub at community scale, which will be deployed at Yarmouth with 3 Tidal T1 turbines rated at 250 kilowatts. These will have a 4 meter diameter center turbine, and the outer turbines will be 5.6 meter diameters on our T1s. We'll then go on to develop what will in effect be our next generation of technology, and that is our sub-hub industrial scale design, where we will be technically developing, procuring and building that with 3 Tidal T2 turbines of 10 meter diameter rated at circa 600 kilowatts. Next slide, please. The Yarmouth Harbour test site really allows QED to set up our sub-hub quayside, test all of our ballast systems and turbines prior to actually leaving quay, and then deploying using a low-cost tug or equivalent, along with our ballast operating barge, or bob as we probably call it. And that quite simply connects to a mooring, allowing us to then deploy our seabed manifold. We then use our ballast barge for remote monitoring, and we'll also have a workboat in attendance to support plant requirements, i.e. for generators, compressors and power loading. Next slide, please. Yarmouth Harbour, with the Harbour Commission, is a particularly key stakeholder within the Tiger project for us, and the facilities in Harbour really have got a great location for port facilities. It's a sheltered site. We've got great wave height, great depths for us to test our sub-hub at, and a great flow of volume at 2.5 meters per second. And also, because of its location, we obviously get access to the ports of Southampton and Portsmouth for supplies, and we can even use our barge for offloading and taking power loading requirements. Next slide, please. There are many supply chain opportunities, as you can imagine, with our project, and I'd like to just give you a little flavour of each of these, and I'll go through that. But next slide, please. First of all, we will need prime fabricators for all our main hull appendages, castings, as well as heavy lift capabilities for the build of the sub-hub at industrial scale, along with the power control units and cross beams, etc. Next. We'll then need solid ballast for payload, and ballast for our sub-hub, which actually goes into our unit. Next, please. Along with this, we'll need plant hire and machinery for load testings, engineering, marine services, and the various sundry works that will be ongoing. So there's quite a lot of plant hire equipment. Next, please. And then again, there will be much first fix and outfitting work, such as brackets, gaskets, and seals. Next. Continuing the theme, we will have much outfitting with our bundles, cabling, and connectors as well. Thank you. Next. And then with sub-hub being submersible and dependent on buoyancy, low pressure air control regulators, accumulator tanks, and controls will form a large part of our project, as will hydraulic systems and control panels, as you can see there, which we've already had in operation in Ireland, but we'll be developing, particularly with our industrial scale unit. Next, please. And then all this will really enable us to establish our integrated energy and environmental monitoring and control systems. So basically we can keep an eye on everything. So instrumentation and controls will form a key part of our project, and we can monitor that from our work boats. And finally, with a sub-hub expected to be at sea for sort of circa 20 years, corrosion protection and use of the anodes, composites, and HDF fairings will be looked at as we develop or aim to develop long-term solutions and make sure we're delivering low maintenance costs. Thank you. And finally, obviously with the turbines, we will have a real requirement for nacelles, castings, bearings, and seals. And in the next slide, you will see our need for generators, power takeoff, electrical cabling, components, and connectors. And then finally, as we develop our industrial scale and our bi-blade design technology, we will be requiring composite blades in the nacelle fairings. Thank you. And then lastly, but certainly not least, we'll be requiring our sub-hub launch, deployment, installation, and retrieval. So we will have in attendance work boats and operating barges. Thank you. Thank you. Last slide. So hopefully that's given you a flavour of all that we at QED are about, what the Tiger project means to us, and the wide scope of supply chain opportunities, and more importantly, the flavour for the supply chain partners that we are looking at developing long-term through the project. Thank you.
Keith, thank you very much for that. Very quick whip through all of the activities that you've got planned within the Tiger project for the Yarmouth site. I'd urge any attendees, if you do have any questions for Keith, please do post them on the Q&A, and I'll do my best to get Keith to answer those. But Keith, in terms of your activities within Tiger and timings, so can you give us a rough indication of when you think the community scale sub-hub might be deployed, and a rough feel for when the industrial scale might start, you might start fabrication, manufacturing of it?
Yes, I mean, first of all, we're developing the Yarmouth Harbour site with all planning permissions and consents ready to take her. We are also, as we speak, have moved the community scale demonstrator from its current site off Ireland, where it's been for 2 years, to Wales and Pembroke Dock, where it has been refurbished and is taking cross-beam and will be ready to be fitted with its T1 turbines. It will then be towed round to the Isle of Wight later in the summer, ready for its deployment there. So that'll be tail end of or later on in the summer. As regards the industrial scale design and development, we are continuing as we speak now. We're live with our design and development of that. Undertaking a fair bit of modelling and analysis and software development on that. As regards manufacturing and build programme, that will be commencing, I'd have to check my programme, but that'll be commencing to next year.
Great, thank you, Keith. So those timings, it probably means there's still the capacity for supply chain to potentially influence the design for the industrial scale. I mean, moving from a community scale to an industrial scale and scaling up, yeah, will have a number of design considerations in there. Is that the case, and are supply chain able to engage with you on that?
Yes, very much so, and particularly around the the power electronics, cabling, and control systems, but also, as you mentioned, the design and looking at different ways or solutions to the ballast. As we particularly around cost, we're looking at driving cost solutions on the ballast side of the sub-hub.
Keith, I've got another question here on the Q&A. Will there be any requirements for forgings? I guess that's probably for the industrial scale sub-hub.
Yes, there may be limited, but some small but limited requirements. I need to speak specifically to the operations team, but there may be small requirements for that. There will be.
Thank you. I've got another question here, quite a direct question, and I know technology developers don't often like to answer this, but do you have a rough idea of what the levelized cost of energy might be for the sub-hub?
Well, obviously we're at different scales. Right now at our smallest scale, with our community demonstrator, we're looking at reductions on our LCOE because of we're not using the same operations mechanisms as other technologies, i.e. we're self-deploying. And also because of the shape of the sub-hub, we were getting more yield onto the turbines, so we're seeing 48% more yield. So our foundation systems are already driving an improvement on the LCOE and that's been shown and evidenced already on community scale demonstrator. So we're seeing savings on the costs operationally and also on yield.
Thanks, Keith. Well answered. And I mean, the whole point for Tiger is that these technologies acknowledge that their costs are slightly high at the moment, and Tiger's all about understanding what innovations are required to get those costs down. And of course, you're going to do that in a step-by-step process. So it makes sense for QED to execute a community scale sub-hub to lead into the industrial scale. I've got another question here, Keith. Are there opportunities for students to engage with your project? In terms of, are they able to carry out research projects and engage with the project?
That's a great question, and one we love, because we've actually already taken on a student just to do exactly that. So one, we welcome it, and I think it's a Tiger project is a wonderful opportunity for students to do it. So that's a really refreshing question to hear. And yes, we have limited opportunities. We can't ask every student. We've already done that, and we would actively welcome that. So we've already taken one on. In fact, they're looking at our tidal and wave analysis and software modeling already.
That's good news. Keith, another question here is about the ballast system and whether you need ballast material, heavy concrete, or can you give us a bit of insight into how your ballast system works?
Yeah, I mean, yes, we've used ballast already in various forms in our community scale off Ireland, and that's something we're already looking at, because the sub-hub could in fact also use, for example, batteries as ballast, which is ultimately weight. So the platform has an option to use, different forms of ballast depending on the solution. So, and cost obviously would form a material part of that. So we can use batteries in one instance, but then there are varieties of form of ballast that we can use.
Keith, you mentioned that the sub-hub has recently crossed the Celtic Sea and come to Pembrokeshire for a refit. What did QED do up at Strangford Lough with the community sub-hub, and were the turbines installed on the turbine for any activity up there at all?
We put she's been in operation in Strangford Lough for just over 2 years, and most of it was to just see the impact of weathering and systems on life and operating and maintenance costs. We didn't have live turbines, and we were not extracting energy from her, so we didn't get any real great turbine or energy data. But what we did get was a lot of operational maintenance data, which will help us design and develop our operations and maintenance policies and procedures.
That's great. Thank you very much, Keith. Okay, I think it's time to move on to the next set of speakers. So if I could introduce Matt Story first. Matt, over to you, please.
Thank you very much, Teo. My name's Matt Story. I'm a project manager with EMEC, the European Green Energy Centre, and we are a development partner for the Perpetuous Tidal Energy Centre, PTEC, and that is what we're here talking about today. So firstly, I'd just like to say it's a real honour actually talking about the Tiger project, which is just so fundamental for the tidal sector at the moment, and it's so critical. And particularly getting to talk about PTEC and how that fits within it, and how important it is really interesting. And I hope you guys are enjoying hearing about it. So today, first I'm going to quickly hand over to both James and Mark, the other presenters, to introduce themselves. Then Mark shall be introducing the project in a bit more detail, and myself and James will then go through the specifics of the project lifecycle, but paying a particular focus on the supply chain opportunities as we go through. So James, do you want to quickly introduce yourself and hand over to Mark?
Yeah, thanks very much. So my name is James Murray. I'm the program manager at Orbital Marine Power. So I'm involved in administering a range of European and national research programs associated with commercialization of our floating tidal technology. So Orbital Marine Power are the world's leaders in the development of floating tidal stream turbines, and we've developed the world's most powerful tidal stream turbine with our O2 tidal technology. In May, PTEC and Orbital announced an agreement for us to supply 15 megawatts of our tidal turbines to the PTEC site. So I'm very much looking forward to highlighting some of the supply chain opportunities associated with our tidal turbines. Thank you.
Thank you, Teo, Matt, and James, and I'd like to extend my thanks to you all for joining today's webinar. I started PTEC many moons ago and have remained involved ever since. And as well as project development, my tidal sector experience includes technology development and fundraising across grants, equity, and debt. So next slide, please. So this is the location of the PTEC project, which is in 3 parts. The offshore generation sites where the turbines will be placed, the subsea cable corridor, and the onshore substation, which will deliver power to the grid. And for your information, in the picture, the arrows represent the direction of flow, and the darker the color, the faster the tide. The peak speed is just over 3 meters per second, and the depth variation is between 35 and 75 meters. The PTEC site is representative of the majority of the global market, so it is a very important project moving forward. So at 30 megawatts, this will generate around 80,000 megawatt hours per year, which is equivalent to around 21,000 homes, or a third of the Isle of Wight homes. To date, less than 20 megawatts of tidal stream capacity has been deployed in the UK. So PTEC can greatly boost capacity and help facilitate the growth of the industry. And this in turn will help stimulate investment, jobs, and supply chain opportunities. James mentioned that we did sign our agreement with Orbital Marine Power, which we're delighted about. That's for 50% of the capacity on the PTEC project. And we're currently speaking to 4 other turbine developers regarding the remaining 15 megawatts. Back in 2016, we achieved full consent, both onshore and offshore. We had investment lined up from a very large company, and we were on track to take the project to financial close and ready for contract for difference allocation round 2. But a change in government policy based on austerity at the time meant that we had to put the project into hibernation. And we've been lobbying the UK government with the support of the Marine Energy Council since to try and reinstate and reform the contract for difference mechanism. And we're hopeful that will take place. And as a result, we reinstated the project and got it back on track last October when we entered a development agreement with EMEC. Next slide, please. So this is the project timeline. It does go back quite a way, but in 2013, that's when we joined forces with the Isle of Wight Council, and we started our environmental impact assessment, and that was the phase 1 consultation process. 3 years later, we got our consents, and we were ready to go. And as I mentioned, the government withdrew the support at that time. So now, 5 years later, we are in the process of completing our consultation, both with all stakeholders and the Isle of Wight residents. And we hope to submit our onshore planning application this summer. Our intention is to have everything back in place. This is the onshore consents. The offshore consents, I should mention, are still in place, but we hope to have everything ready for the contract for difference application towards the end of this year, in which case we would then be ready to start construction in 2023 with operational launch in 2025. Between consent at the end of this year, assuming we get it, and construction, we'll be going through a very robust procurement and supply chain exercise, which will include more meet the buyer events, hopefully in person, and a very, very strong procurement activity. So we look forward to discussing that further with you all then. And then operations, we're just assuming 15 years to match the contract for difference timeline, with decommissioning the early 2040s. So that's really the timeline and a bit about the project, and look forward to answering any questions you may have. And I'll pass you over to Matt.
That's wonderful. Thanks, Mark. Fantastic. So yeah, we're going to go through the project timeline, and Mark and James, I'll give you an opportunity at the end of each slide to add anything as well that you may want to. But first up, we're talking about development. So essentially, the development phase of the PTEC project runs from when we commence reconsenting back at the beginning of this year, right up until the commencement of the construction works, which is like in 2023. This is going to require a significant amount of support from across a supply chain. And so I've outlined some of the key areas here where we can strongly foresee we're going to need expertise. So first and foremost, environmental consultancies and specialists. The reconsenting of site is crucial, and a big aspect of that are things such as environmental impact assessments. So these packages of work will be fundamental to the successful delivery of the project. Additionally, planning and architecture experts will be required, again, as part of our onshore planning consents, as well as supporting the actual design or the initial design of any onshore infrastructure. Secondly, as we begin to build up the construction phase, we'll require procurement specialists, quantity surveyors, and potentially additional supply chain support. This will allow us to actively build a supply chain for the next phase of works and begin to have that in place as we move into construction. Additionally, an incredibly important aspect of what we're doing here is trying to build engagement with the local community, both formally through the consenting process, but also informally. And that's pulling in expertise and pulling in ideas from the Isle of Wight. And therefore, stakeholder engagement and marketing will be crucial to that. And that's something we're already drawing heavily upon the local area. And finally, as we move closer to the construction phase, beginning to bring in civil structural electrical designers will be crucial. That initial concept design through to early detailed design is going to be fundamental to the project. And again, something that we foresee a big need for going forward. So I don't know, Mark and James, if you want to quickly add anything at this phase, or if you're happy for me to move forward. All good?
Yep.
Wonderful. Right, can I go forward, please? So the next phase, so we'll be looking at construction, and we split this out into onshore and offshore, as it'll require some similar but quite different specialities. So probably worth saying initially that the actual onshore construction, although quite a bit of work, will be pretty minimal in terms of visual impact. It'll include an onshore substation, which will be highly architectured to fit in the local environment, some landscaping works, and also some cable runs, but actually still require a significant amount of supply chain support. So first and foremost, and as with the previous, civil structure and M&E designers. So we'll need detailed design of all assets and mechanical and electrical aspects. We'll require, and it probably goes without saying, but contractors / construction companies to take on the overall construction project and the building of the substation, as well as management of the construction process as well. Material suppliers, potentially labour suppliers as well, to make sure that we have the right people and the right materials for the actual construction of the project. And finally, health, safety and environment specialists, making sure that we're delivering the onshore elements in the most sustainable and of course safe way possible. So again, standard expertise you require within a construction phase, but again, it's going to be incredibly important for us. Anything Mark and James you'd like to add? Happy to move forward. Okay, wonderful. And then the offshore side, if we go forward a slide, please. So the offshore engineering will represent a very important part of the project. Essentially, this will include all of the design and delivery of the offshore electrical infrastructure and also the tie-in with the local grid. So that's the SSEN local grid. And again, we're going to require quite a significant number of specialists in order to help us in this area, including marine civil electrical specialists, so leading on the design and delivery of the offshore and the electrical work. Again, a very specialized high value area which we'll need to procure. We'll also need to bring in specialist marine contractors to deliver the actual offshore construction, including working at sea, facilitating access, and actually managing the offshore construction process. And as with the onshore element as well, we'll need to make sure that we have the right materials and specialist equipment, and therefore we'll need the right suppliers. So we get a significant amount of electrical and mechanical infrastructure to be equipment, to be purchased. And finally, again, environmental and health and safety consultants, it's going to be fundamental throughout the entire project, and that's a big area where we know we're going to need support. And then if I can move forward on to the operations phase, and this is going to represent by far, at least from a timeline perspective, the most significant part of the PTEC project. We're anticipating to be fully operational around 2025 and to 2026. And then operational for a 15-year period of time. So that's a long time, and a great length of time that we're able to build basically build a supply chain around us for operations. So again, we're going to need marine contractors providing at-sea support, both for the maintenance and operation of the PTEC site. You'll notice, obviously, because of the nature of the project, marine is fundamental to us, and we're very, very lucky to be based where we are on the Isle of Wight, which has incredibly strong both maritime heritage, but also existing maritime industry. And we are providing an opportunity for those local businesses to upskill in this area and actually support us, and that's brilliant. So we very much look forward to working with local ports and companies in this area. And that is equally as true for boat hiring charter companies. We'll need to be able to access the site, both for personnel and visitors, tourists, and dignitaries. We're looking to build an area of expertise around this project, which we're intending to get people to visit. In addition to those support roles, we also be directly employed roles during this phase for employees to manage the day-to-day running of the site. And additionally, as a sort of an add-on benefit to the local area, we anticipate hospitality and accommodation supplies as well. This is something that we've seen quite significantly through EMEC on Orkney, and being able to grow in sort of an additional hospitality and accommodation, as well as growing supply chains around our projects. And we fully intend to look to do the same on the Isle of Wight. So I think that gives a bit of an idea of sort of the main construction operations phases. I'm now going to hand over to James, who's going to talk about the project from a developer's perspective and from a technology perspective. Thanks, James.
Thanks very much, Matthew. So yeah, I'm just going to focus today on the tidal turbine technology, and what I mean by that is the platform itself, the moorings, the anchoring, so all the associated contracts associated with the build of our units, and then the operation and servicing of them over a 15-year project life cycle. So firstly, just I think a number of you may not have heard of orbital marine power or the technology before. So firstly, some background on the company and the technology. Orbital Marine Power were formed in Orkney in 2002 with the sole focus of developing a low-cost floating tidal technology. We've designed, tested, and demonstrated the technology at increasing scales over the past 15 years or so. Most recently, we demonstrated a 2 megawatt prototype, the ESTER 2000, from 2016 to 2018 at the European Marine Energy Centre in Orkney. And that unit produced over 3 gigawatt hours of electricity and really demonstrated the technology at full commercial scale. From 2019 to 2020, we built our first commercial demonstrator, the Orbital O2. And this machine is very similar in model to the type of machine we would plan to install at the PTEC site. So I think it's very important to look at what we achieved from both a kind of a local and national supply chain opportunities on that first unit. So that O2 turbine, which we installed in Orkney just last week, we achieved 80% local and national supply chain content with that first unit, and the entire unit was procured from within a European supply chain. That single unit will produce enough electricity for about 2,000 homes and offset around 2,200 tons of carbon dioxide per year. So in a lot of ways, our technology is very similar to a floating wind turbine. Has a lot of the similar components. But I just wanted to point out some of the key differentiating factors associated with our technology and with tidal stream energy in particular that has pertinence for the types of supply chain contracts that will be available. So I think the first thing to say is that we've always been focused on developing the lowest cost tidal stream solution. And for that, we endeavor to carry out all operations, all maintenance operations with low cost workboat vessels or small rib style vessels. And for us, it makes sense for those vessels because they're small, they can use small, modest harbors to be entirely based locally. So we can use much smaller vessels that have higher rates of maybe only 1,000 to 3,000 pounds a day to carry out all installation and maintenance operations associated with our technology. So immediately there's a very significant supply chain opportunity there for both workboat and rib style vessels, and also local onshore maintenance facilities associated with our technology. So as I said, we're planning to install up to 15 megawatts of units at the PTEC site. So we would be starting fabrication on those around 2023 into 2024. We're also planning to build an additional unit in advance of PTEC starting next year. So approximately 8 units we've got planned between this unit and 7 units for the PTEC site. But I think it's really, really important to say this is really just the tip of the iceberg in terms of tidal stream energy, both in Europe and globally. We estimate that there's at least 2 gigawatts of tidal stream potential between the UK and France, deployable before 2030, and additional gigawatts of potential between long term in France, and over 100 gigawatts of tidal stream potential globally. So this is really just as I say, the tip of the iceberg in terms of supply chain opportunities in what is an entirely new generating sector. So I'm going to move on now to the kind of some of the construction opportunities associated with our technology. So the O2 tidal turbine is composed of around 600 tons of fabricated steel. So both within the overall platform, you can see this big long yellow 72-meter tube, and also the legs, the nacelles, and the pitching units. These are all made of fabricated steel, as well as the actual anchors themselves sitting on the seabed. So all of these sections are entirely road transportable, and it was very important for us when we're looking to boost supply chain capacity in the sector, recognizing we're coming from producing single units, but very quickly as we reduce our costs, we're going to start to see multiple units being deployed. So it's very important that the supply chain has the capacity to grow alongside our technology as we reduce costs. And so it's very important that we can share our designs of our units, introduce flexibility around the supply chain that we can use with our technology. So as I say, all the sections are entirely road transportable. So all of the sections can be fabricated either coastally or inland, with the final fabrication and outfitting of the machine occurring at a coastal location to allow us to load the entire machine into the water. Next slide, please. So following on from that theme of enabling the suppliers to grow alongside the sector, we tend to use standard steel fabrication, standard steel grades and welding techniques associated with all the fabrication of the superstructure of our technology. The entire structural fabrication scope can be executed by either small to medium style enterprises or large fabricators. And indeed, for the first O2 tidal turbine, every single contract associated with the fabrication of the seal superstructure was carried out by either small or medium sized enterprises. So I've talked a lot about the steel fabrication opportunities there. And as I say, it's 600 tons of steel and a number of multiple different sections. So a lot of opportunities there. I'll move on now to the other supply chain opportunities. So as I say, ultimately, our turbine is very similar to a wind turbine. One of the differentiating factors is we've got two powertrains connected to a single power conversion section within the hull itself, as opposed to a wind turbine, which has essentially one powertrain per platform. So as you would expect, we've got composite blades on either side of the machine. They're around 10 to 12 meters in length, each blade. So not of the same scale that you might see on large wind turbines. So there's potentially an opportunity there for smaller suppliers to get involved into supply of composite blades for our tidal turbines as well. The moorings are made of both chain and synthetic, and they weigh over 100 tons per unit. So very significant moorings there. So there's an opportunity there. And again, they were sourced from within a national supply chain for the first O2 unit. We will have dynamic cabling. That's essentially a cable going from the seabed up to the from the site infrastructure up to our tidal turbine. That is will have some significant cable protection on that. So that's what we refer to as dynamic cabling. There'll be one of those per unit. And then there will be hydraulic cylinders essentially in a hydraulic system for leg actuation. So with our tidal technology, the nacelles, the pitching units, and the blades are connected to retractable legs that can be lowered below the waterline for generation or lifted to the surface for on-site access with those low-cost workboat vessels. So those legs are actuated with hydraulic cylinders. So again, for the first O2, they were procured again from within a national supply chain. So there's very much the capability there from existing sectors to supply those hydraulic power units. Ultimately, it is a large electrical device. So there's 690 volt generators. There's power converters within the hull themselves. There's an 11 kilovolt transformer within the hull itself, and all the associated cabling and switchgear to interface between all of those individual systems. There's obviously then all the heating, the lighting and ventilation systems and control systems associated with a turbine generating unit. And again, all of these systems in our experience are procurable from existing sectors. There's not a particular need for complicated bespoke systems. What we tend to do is ensure that our tidal technology is as accessible as possible. We don't necessarily have to build in really high levels of redundancy and build and design particularly bespoke components. So we can often work with a lot of standard off-the-shelf existing systems for the overall fabrication and outfitting of our tidal technology. So as I say, lots of opportunities there associated with the delivery of 8 units over the next 2 to 3 years. What we're going to be doing for the PTEC site particularly is shortly commencing a supply chain mapping exercise towards both informing a procurement strategy and a plan. Some of the key focuses will be understanding where that local maintenance could take place. Can it take place locally? What the suitable harbors are like? What are the suitable storage areas and laydown areas where we could, for instance, locate strategic spares and a maintenance base for our technology? But then also the final assembly of the technology, again, confirming whether that can be based locally or regionally, the final connection of the hull sections, the legs, the blades, the painting, the outfitting. Again, we're very keen that that can take place locally or at least regionally as well. So we will be commencing that supply chain mapping exercise over the next few months, but I would very much encourage any potential suppliers who think they might be able to supply any of the scopes they've learned about today to get in touch. So yeah, that's everything from me today. Happy to answer any questions. Thank you very much.
James, Matt, and Mark, thank you very much for the overview there and the insight into the PTEC project. It's certainly a very important project, I think I can say, with from the perspective of the tidal stream sector. You know, it gives tidal developers the opportunity to start demonstrating the scale up in terms of volume, so numbers of devices, which we haven't necessarily seen quite yet. There are a couple of projects, the Maygen project, for example, and Nova Innovation also deploying multiple devices, but PTEC is a real opportunity for other technology developers to potentially deploy at scale and volume. Okay, we're running slightly ahead of schedule, so I'm pleased to see that we do have a few questions in the Q&A. But I thought perhaps it might be worth just starting, and it's up to Mark or James who wants to take this question, but could you just explain what the setup is between the Tidal developer and PTEC as a site owner operator? And in terms of supply chain, you've effectively got two channels there to go down to engage with on this project.
I'm happy to kick off, James, if you're okay with that. Sure. So PTEC, we're really a site developer. We want to operate the sites such that we effectively rent the seabed to the turbine operators. So this is the likes of Orbital Marine Power, it could be QED, and they will have their own special purpose vehicle, and that will be the company that applies for a contract for difference and has all its separate project agreements. We will then have a berth agreement and a sublease with the Crown Estate, and that will be the relationship. So PTEC itself will have its own procurement for the onshore infrastructure. That includes the substation building, control room, transformers, switchgear, etc. And Orbital Marine Power will have its own supply chain exercise, but we'll work very closely together and share those strategies and plans to ensure that we optimize the opportunity for everyone in this region, but also locally in the Isle of Wight. As for the business model and commercials, that's still under discussion, but we're working on that with Orbital and the other turbine guys. James, is there anything you wanted to add?
No, just to say, yeah, I think, as you said, that the kind of the two procurements will be separate, but we will need to work very closely together. It's very much in all our interests that we can maximize the local benefit associated with this project. So we will be doing our own separate kind of procurement mapping and strategy exercise, but we will work very, very closely together.
Yeah, and I guess the location of the PTEC site plays into that in terms of the nautical history and the industrial history of the area and the Solent there. So, okay, we've got another question here about the types of turbines that might be deployed at PTEC. We've obviously heard from James and we've seen what the orbital device looks like, the O2 device. But Mark, are you able to give us an idea of what the other technologies might be or might look like at PTEC?
Sure, it's a really good question actually, and based on our consultation with residents, you know, we do listen to them, and we want to make sure that you know, it is a beautiful area. We want to make sure that impacts are minimized, and this includes visual. So Orbital 2 at 15 megawatts will be 7 of their turbines. Now, when we previously got consents, we had consent for turbines surface piercing up to 9 meters above the water surface. So the freeboard of Orbital 2 is 1.7, so it's likely to be under 2 meters. So a lot less than we've got consent for. For the remaining 15 megawatts, it's very likely that all turbines will be submersed. That's the current plan. And the companies we're speaking to are designing turbines to that effect. It remains to be seen, but it's very likely that that will be the setup.
Thank you, Mark. And we've got probably another sort of relative question in relation to that, was about concerns for deploying tidal turbines in a bay, such a busy area for navigation and recreational use. I'm assuming this is all tackled through the consultation process, but can you just give us an indication in terms of what the status is of that consultation?
Yeah, sure. So just to be clear, the current consultation is for the onshore planning. The offshore consents remain valid. Now, when we undertook that process those years ago, there's a huge amount of effort went into assessments and surveys, including around the island race, shipping lanes, etc. And the PTEC site has been chosen in that location because the round the island race is within. It's between the PTEC sites and the Isle of Wight south coast. The shipping lanes are way to the south. So site selection, we were very careful with that. What we did do recently was extend what's known as a Section 36 consent, and it basically means that we're extending the timeframe within which we can start construction. And as part of that process, the Marine Management Organisation went out to all the relevant statutory consultees and discussed this aspect with them. They had no concerns. So as we progress, and once we have got onshore consent back in, then we will undertake further consultation, not because we need to, but because we want to, as a company, along with our partners Orbital. And we understand that people, you know, may have concerns about navigation, but we've done a lot of analysis on that. And some of the feedback has been that they much prefer the surface piercing turbines because they can actually see them. In fact, that was the majority of the feedback from users of the sea, was that they did prefer turbines they could see. So it can be quite subjective, but we're undertaking it in a very professional manner. And James, is there anything you want to add on navigational risk and your experiences with Oracle?
I just, again, I feel like these things can be dealt with through the kind of the standard EIA processes. There's the standard mitigation, and that's been successful because obviously PTEC is the offshore consents have already went through. It is already consented for floating tidal. There are a number of other projects around the UK that have been consented for floating tidal. You know, where we operate in Orkney, we've got 3 inter-island ferries crossing our deployment site every single day. So, you know, typically, through, you know, early engagement, appropriate mitigation measures around lighting, marking, you know, and just kind of recognizing, you know, leaving space for navigable channels, etc. These navigation risks can be, you know, dealt with in the same way that other potential impacts can be through the EIA processes.
Great, thanks guys. And we've just literally just had another question here. Will PTEC be looking to procure a fisheries liaison officer as part of the engagement process, or as you sort of suggested there, Mark, the offshore side of things is the consultation is already completed? So
yeah, it's a really good question. We did have a fisheries liaison officer as part of our consenting process. Now, while we have consents, we do have conditions of those consents, and before we can start construction, we must discharge all those consent conditions. And the big one, of course, is commercial fisheries. So once we've reconsented on shore and ready to go and complete the final development steps towards construction, then yes, we will engage with a fisheries liaison officer to help us with the fisheries discussions. And of course, part of that includes a requirement for us to enter into a joint operation agreement with the fisheries.
That's great, thank you, Mark. Okay, we've got another question here about offshore electrical equipment and whether there are still opportunities for new suppliers. I don't know whether that's aimed towards PTEC or probably Orbital, but do you have any more detail you can give us on that at all?
Yeah, I mean, in terms of the tidal turbine, it will be an open procurement process. So we've got the generators, the power converters, are the main bits of equipment, and then the transformers themselves. So yeah, it will be an open procurement process. So there certainly will be opportunities. There's probably not a huge amount of kind of entities in the market that can kind of provide those types of scopes. Where there'll also be opportunities will be around cable protection, around the cabling itself, all the various switch gear, potentially some contracts for the outfitting as well, and then the offshore electrical operations. So helping with the energization of the riser cable and the energization to the wider PTEC electrical infrastructure. So yes, there'll certainly be it'll be a fully competitive tendering process associated with all of that.
Thanks, James. There's another question here specific to Orbital again, and that's whether you'd be seeking Lloyd's or DNV approval, or
Yes. So the entire machine is I think it's typically the DNV are the standards that we would typically follow for the design of all our offshore generating equipment, and then there will be kind of third-party verification as well of our designs of all. And the most important things they look at are the kind of the loadings on the machine, the kind of fatigue loadings, the extreme loadings on the machine, on all of the various systems that are designs, and ultimately the fabrication has been executed in accordance with those standards. But yes, it tends to be kind of DNV, the standards that we tend to adhere to.
Thanks, James. We've got another question here, LCOE related. So you can guess who that's for, James.
Yeah.
What's your target LCOE?
I think, I mean, I could probably speak as an industry. So as Mark kind of alluded to earlier, there was revenue support in place for the tidal stream energy industry when PTEC was previously consented, and that ring-fenced tidal support was withdrawn. The sector is looking for a ring-fenced support for tidal stream energy, because it isn't practical that 7-unit machines are competing on price with 1-2 gigawatt offshore wind farms at this stage of the industry. Not to mind the slightly earlier stage of the technology, just in terms of cost of financing, economies of scale. It doesn't make any sense. So what we're asking for as an industry is an administrative strike price of £250 per megawatt hour for the first 100 megawatts of installed capacity in the upcoming contracts for difference auction, which will be opening in December of this year. But really, it's all about that. Once we can get that first kind of 100 megawatts in the water, we'll start to see prices plummet. But we need to start seeing projects like PTEC getting off the ground, and we can't really see a situation where that ring-fenced support is withdrawn or isn't forthcoming once more. We've got a really excellent opportunity to commercialize the sector over the next few years, and with all the associated supply chain benefit that we've heard about today. Thanks,
James. Yeah, I think I can echo that as well on behalf of the Tiger project. Tiger will actually be sort of looking to collate all of the information and data from the various Tiger deployments and also deployments outside of the Tiger project to come up with an updated cost reduction pathway to where, what will the LCOE of this technologies be in future when we start deploying at volume and at scale. So very much a watch this space for Tiger in terms of the reports that we'll be issuing in the not too distant future. Okay, I think it's time to draw the Q&A session to a close. So if I can move over to the next slide, just a quick reach out to all of you who have joined us today. The Tiger project is looking into the manufacturing roadmap for the tidal sector. And so we really want to engage with supply chain and understand what your capabilities are currently, what your appetite might be to engage with and supply the tidal sector in future. So I'd urge you, if possible, to take part in this Tiger questionnaire. Yeah, thank you anyone who can participate. I think it's quite a short questionnaire, but it'd be really valuable to us as a project for any responses that we get. Next slide, please. So just finally, a quick wrap up here. So I'd like to say thank you very much to all of our speakers today for the insights into those projects and for answering all of those questions. Thank you very much for that. Thank you very much to all of our attendees today. And a special thank you to Laurent, who's been interpreting this event. The mind boggles as to how you can do that. So thank you very much to Laurent. Just for anyone who would like to learn more about the Tiger project, please do visit our website, www.interregtiger.com, and you'll find all sorts of information about the basic principles of tidal stream through to what the ask is from government in terms of a revenue subsidy, through to all the different projects and technologies going in the water there. And you can see on screen here, just to say that please do reach out to the individuals to discuss any opportunities to engage with them on their projects. Tiger is all here about building up that supply chain engagement and making those opportunities come to fruition. And anyone who has a broader interest in tidal stream or the catapult or would like to learn more about the tidal stream industry, please do get in contact with myself. I'd be more than happy to introduce to you the subject and make any other introductions that you might need. So that's it. Thank you very much, everybody. And we'll see you at the next Tiger webinar, whenever that may be. Thank you.